Hi, grade 12. Let's start today with a new chapter. Our chapter today is chapter 2, motion in one direction. Motion in one direction, this chapter contains 3 sections. The first section, displacement and velocity. Second section will be acceleration, and the third section will be falling object. Let's start. First, what is one-dimensional motion? One-dimensional motion means the motion in one direction. For example, to simplify the concept of motion, we will first consider motion that take place in one direction, like a train. Train have starting point, ending point. A bullet come out from a gun, have a starting point, ending point. This called one direction motion. So one example of the motion is commuter train on the straight track. To measure motion, you must choose a frame of reference. For example, if you are in the ferry between Port Said and Port Fouad, and the ferry is in the center of the water, in the middle of the water, and you want to make sure the ferry is moving or not. The first step, you must have a frame of reference. The frame of reference is something that you sure it is not moving, like a tree on the land or a building. So with your eye, you must check this building. If you feel it is moving, this means what? This means your ferry is moving in the water because you're sure that the frame of reference is not moving. So this is how to make sure that you are moving or not. And also you use the frame of reference to measure the motion. The distance from the frame of reference for every second tell you the distance you moved. If the distance from frame of reference start, for example, 10 meter, after 10 seconds, it's turned to be 20 meter, so you moved 10 meter only. And let's check the small video that explains this.
A train moves from one station to another on an Earth that is rotating and revolving, and in a solar system and galaxy that are both moving. A frame of reference is defined to simplify the description of the train's motion. The motion of this gecko can be described by imagining a meter stick placed under the gecko to define a frame of reference. Observers in different frames of references will see the motion of objects differently. The red dot in this picture is a stunt dummy dropped from the plane. From an observer in the frame of reference of the moving plane, the dummy appears to drop straight down and splash in the water. And from an observer in a stationary frame of reference on the ground, the dummy appears to fall in a curved path.
Okay, as you see here, the frame of reference is something that tell you you are not moving or you are moving, and also it tell you how big is the distance you move from the frame of reference. Okay, next step, let's talk about displacement. Displacement is the change in position. Displacement is not always equal to the distance traveled. So sometimes distance is not the same as displacement. SI unit of displacement is meter and its sample is m small. The change of displacement or change of position of this animal from this point x1 to x final or xi initial to x final, if you subtract these two x, the difference between x final and xi give you the change of displacement that this object covers. So we always subtract final position minus initial position to get the displacement. Okay, we have positive and negative displacement. Just a minute. Let's check the following video which explain how displacement could be measured.
As any object moves from one position to another, the length of the straight line drawn from its initial position to the object's final position is called the displacement of the object. Displacement equals change in position, or the final position minus initial position. If our ball travels from an initial position x equals 12 meters to a final position x equals 35 meters, the displacement is 23 meters. But what happens if the ball travels from the 35-meter mark to the 12-meter mark? If the ball travels from an initial position x equals 35 meters to a final position x equals 12 meters, the displacement is negative 23 meters. Keep in mind that the displacement is not necessarily the total distance covered. If the ball were rolling along from an initial position of 12 meters, hit a wall at 35 meters, and rolled back to a final position of 18 meters, the overall displacement is only 6 meters. When working with displacement, always look at the initial position and the final position of your object.
Okay, as you saw in this video, we noticed that displacement is the difference between the final position and the initial position of the object. Now we have here sometimes negative and sometimes positive displacement. This according to the direction of the motion, not according to the distance it's covered, because there is no negative distance. And this is the first case from 10 to 80, and 80 is the final. 80 minus 10 is 70 centimeters. This is the first displacement, and it is positive direction. The second one from 3 to 12, so this is the object moved from 3 to 12. 12 minus 3 equal 9 centimeters in positive direction. Also here from 10 to 6. So in this case, the initial is negative 10, and here is positive 6. So the object moved first 10 here in the negative, then 6 in the positive. This is 16 centimeters moved in this positive direction. Now let's go for the negative part. As you see, the final is always this direction and the initial here. In this case, the final is 20 and the initial is 80. 20 minus 80 equal negative 60. Negative means it's moved in the opposite direction. So the negative here will be opposite direction. Okay, this will be everything for today. You must understand displacement and how we measure displacement. Thank you for your time. Goodbye. See you next time.